So, graphs of logarithms, okay? What I'm going to do is I'm going to draw the following graphs for you, okay? Here's what we're going to do. We're going to do y equals log x base 10. Are we cool with that? Now, let's figure this out. So, undo. Alright, so, and let's edit this. So, y equals, I'm just going to keep it as base 10 if possible. Oh, they have base 2. Excellent, never mind. So, log x base 10. Now, what you're going to notice is that it stops working here for some reason. See the way it keeps going to 1? It never makes it to 0. You get what I'm saying? Never, ever makes it to 0. Now, where's the other part of it? Alright, what else can you say about logs? That the x value is always, it's always increasing, isn't it? That makes sense? X value is always increasing. Now, why doesn't it have the negative in there? Alright, so that's the first two things we notice. Give me 1 second. Alright, so would everybody agree that log graphs are always increasing? Why are they always increasing? Because the y value is always on its way upwards. Does that make sense? Why doesn't it go by the y-axis? Why doesn't it go by the y-axis? Why is there no answers over here? Let's try any log negatives. They don't exist. Okay, go with that. What's log 0? Log 0 is mad error. It's undefined. It doesn't exist. Why doesn't log 0 exist would be the next question. Can anybody tell me why doesn't log 0 exist? Anybody have an idea? Let's find out. Alright, let's start off with 2. Alright, what's log 2 base 2? 1. Alright, so 2 to the power 1 is 2 to the power 0, 1 to the power minus 1, to the power minus 2. Oh, damn, it will never actually reach 0. Do you get what I'm saying? It will become a really small fraction, but it will never reach 0. So any base 2s, for example, if I said log a quarter base 2, what would the answer be? What's a log quarter base 2? Using the information I have on the left. The answer would be minus 2. Yeah? But if I put in log 0 base 2, that's impossible because this will never ever be equal to 0. Does that make sense? There's no power I can put in there that will make it 0. If I put in minus 1,000, it's practically 0, but it's not. Okay, that's the point. It can never ever be 0, and this is reflected in the graph. It gets ridiculously close, but it never makes it. See the way I'm dragging it away from the x-axis now? And also what it does is it doesn't make it to the y-axis. Okay? Next thing. What is the difference between log x? Okay, so log x is log 10 base x. Excuse me. Where am I? So I drew this graph already. Everybody cool with that? Can anybody tell me what will be the deal with this graph here then? What do you think will happen? Let's find out. Any predictions? What do you think will happen? Up, you said? Okay, let's find out. Plus 2 shifted it to the right, to the left 2. Why? Why did it do that? Because if I put in x equals minus 1.9, does that log exist? Why does it exist? Because the log will be 0.1. The answer exists now. So by putting in a plus 2, I can now have negative values of x that actually exist. Can anybody tell me what will happen if I do log x minus 2? What will happen there? Will x equal 1 exist for that? Because it'll be negative log. So that will have the effect of shifting it to the right 2. So let's find out. Everybody cool with that? So far, so good. Now, what I'm going to ask you next is, what is the observable difference between, or say I'll redo that last one. There you are. Now, next thing I'm going to ask you is, what is the observable difference between log x plus 2 and log x and then a 2 over here? They look the same, don't they? But do they behave the same? Any predictions? We already have y equals log x base 2, or sorry, log x plus 2 base 10. And now we have this graph here. Any prediction on the difference? Let's find out. The original one is log x. The one to the left is log x plus 2. Now we're going to do y equals log x. Sorry, log x. And then over the other side, I'm going to put in a plus 2. So we get the same thing, and then I'm going to put plus 2 there. What have I done? I've shifted it up 2. The y-axis was affected this time, not the x-axis. What happens if we put in minus 2? It shifts it down 2. Everybody cool with that? Next thing I'm going to ask you is, what happens if I put a number in front of it? See the way we have y equals log x. What happens if we do 5 log x? What would be the effect there? It makes each value 5 times higher. You multiply it by 5. Let's show you. I'm now going to do delete. Next one I'm going to do is 5 log x. Now what's the oof. Let's see. Let's zoom in. Let's zoom in and see is it the effect I was looking for. Okay. Now I'm gonna need my definitely gonna need my drawing apparatus here. Okay. A really close look. This one's log x, and this is 5 log x. Now, this answer here is roughly 0.3. Would you be cool with that? And this answer here, 1.5. Is it 5 times taller? That makes sense, doesn't it? What would be the effect of multiplying it by minus 5? What do you think would happen? Alright, let's find out. What did I do? I'll undo it again. I think I'm mirror imaging it in the x-axis. Look closely. That's minus 5 log x currently. Everybody see it's mirror imaged in the x-axis? I'll draw both of them at the same time just to be sure. Cool. Mirrored in the x-axis. Now, move on. You guys are going to be asked to draw these, okay? Now, the next thing, oh yeah, comparing a to the x with log x, alright? Let's do that. Next thing I'm going to draw is this. I'm going to draw log, again, sorry, 1 sec. 10 to the power of x versus 10 to the power of x, right. X base 2 and 2 to the power of x. Do you see the way one of them is the opposite of the other one? For example, lads, what we're going to look at here is, okay, I'm back over here, aren't I? Alright, one of them is the opposite of the other one, okay? So for example is, back in the day we would have said log 8 base 2 equals 3, you get that? But then 8 equals 2 to the power of 3. Long story short is that when you draw these two graphs, I have a log base x here. Just give me a sec. Base 2, isn't it? So I'll see if we can adjust that. Base 2. 1 sec. I'm currently drawing log base 2. And I'm doing an x there. So that's x base 2. Everybody cool with that? You just enter into your table function and it'll give you out all the points. Cool with that? Now I'm next going to draw y equals 2 to the power of x. Using my table function. Now, if you draw the line y equals x, does everybody know what the value y equals x is? 1, 1, 2, 2, 3, 3, 4, 4. Guess what happens? They mirror each other through that axis. So they essentially mirror each other through the line y equals x. See the way they're reflections of each other? The top one is 2 to the power of x, and the bottom one is log x base 2. Okay? So in class, you're going to, for homework, you guys are going to draw 2 and 3, questions 2 and 3, and you're going to draw 6, 7, and 8. 2, 3, 6, 7, and 8 for tonight. Just try and draw them out mainly using your table function, and then we'll correct them tomorrow and try and get on to the last exercise.